Hello, I am Swati Verma, Assistant Professor, Chhattisgarh Swami Vivekanand Technical University, CSVTU, Bhilai. I welcome you all to the course on Industrial Automation and Drives. Today, we will begin with our 39th lecture of the course with the title SCADA Programming Part 3. In the previous lectures, we have covered the visibility properties, the touch push button properties, and at the last we have covered object size properties. Okay. Till in the previous lectures in the SCADA programming 1 and in SCADA programming 2, we have learned how you can add the components in your window in the software, how you can set the properties, various properties of the window. First the location, second the visibility properties, the touch push button properties, and also the size properties. Okay, and how we are linking the objects by using the tag name. Okay, so now in this lecture we will go in depth about this SCADA programming. Okay, first you can we have seen that initially in the previous all the examples which we have discussed, we are linking our switches to the light indicator by using the tags. Okay, means for example in the slide, if we are using the slider with a tag name SL, then we are using the same tag name in the light or in the light wizard. In the light wizard for the expression side, we are entering the same tag name of slider. So by this we are linking both the slider and our light indicator, so that when we are making the position or changing in the switch status, it will reflect on the light indicator. So when we are turning it on and off, it will change the status of our light indicator to turn on and off. Okay, but in this lecture we will learn the SCADA scripting for the logical development. Okay, the tags, through tags also we can interlink between a switch and the light, but there is one more method through which we can connect them or interface them, which is called as script method. Okay, so in this lecture we will cover this method or this script called script method to interlink various components of switch and light. Okay, so for this example again we have to select first a switch from the wizard and a light indicator. The steps will be same. You have to click on the wizard option, various options will appear, then you have to go to the switch, then the various what are the different types of switches are there will be appear, then you have to select which type of switch you want. Similarly for the light, you have to click on the light indicator, and there various amount of all sort of light indicators will appear, and you have to select which light indicator you want. So I have selected one switch and one light there. Okay, so when you click on the switch, it will ask for the tag name. Okay, so I have added SW as the tag name of my switch. Next, when we click on the light, here I have given the expression in the light wizard, I have given the expression lamp. Okay, here I am not giving the tag name SW like we did in the previous example to interlink light and switch. Okay, so till now they are not connected because the device tag names are different. We are using SW for switch and lamp for the light indicator. So we are not using the tag system to interlink them. Now we will use the script method to link our light and switch. Got it? So here we have given the different expression for the light like the lamp. Here also you can choose the another the fill color of your choice. For the 0 or the off condition I have chosen red, and for the 1 or true or the on status I have chosen the green color. Like I have said, you can also use a blinking effect like in the alert when you want to give the siren for any fault condition or for any accident. There we want the blink option so that it attract the personal, so that sudden, if you want a sudden immediate action to carry on. So here in that applications we use the blinking effect. So here you can, when you want that blinking, you can check on the enable blink, and it also gives you freedom to select the blink rate, either fast, slow or the medium range. Okay. So, now we will see how we can interlink our switch and the lamp by using a script method. Okay. So, you can see in the development window, when you will right click on the anywhere on the development window, this window will appear, that repeat last object, undo, erase, paste, save the window, close the window, delete the window, save window as, okay, window scripts, quick functions, smart symbol, window properties. These basic functions will appear when you right click on the development window. From here, we will select the window script to add the script. Got it? You just only have to right click on the development window. This window will appear. From there, you have to select the window script. After selecting the window script, this type of window will appear, as you can clearly see in the figure. At the title, you can see the condition type and the entry milliseconds. Okay. What is the condition type? When you click on the arrow of the condition type, there are 3 options. Okay. When you will click on the condition type, currently it is showing while showing, okay, but there are 3 options: on show, while show, on hide. So, what does it mean? On show means when you are going to the run time. While show means when you are in the run time. On hide means when we cross the run time. Means on show means whatever things or conditions you want during the runtime, or when you are going to start the runtime, or you can say in the simpler words, you can say the initial condition. Like we did in the circuits, we call the initial condition. Similarly, when you are going to the runtime, that time what conditions you want, it will comes under the on show. Okay. While show means the conditions which you want to appear or to satisfy or to be true during the runtime process. Okay. For example, I want that throughout the runtime, I want my status window should be on or my indicator should be on. Okay. Then like this I have to put that expression or that condition inside the while show. On hide means when we cross the runtime, means after the runtime is over, what condition you want. Like I have given you an example that during the while show, for example, before the start, my indicator should be off. During the process throughout, I want that my indicator will be on, indicating that process is in run, and when the run process is off, I want it to off. So, my indicator will be off. Got it? For example, like if you can see in the daily appliances, and when you turn on your microwave oven or simple you or any TV, when you switch on the supply, a light will appear, a green light will appear, which indicates that, oh, it's turned on. When it is turned off, it becomes red. Okay. So, this is the on time, while time and the on hide. Before the run time, whatever conditions you want, during the run time, whatever conditions you want, and after you cross the run time, whatever conditions you want to satisfied. This comes under 3 condition times: on show, while show, on hide. I think this is clear. Okay, we will move in the deep details through the practical example also. Okay. So, as you also see in the figure, we have lots of options available: if, then, and if, else, else if, and, or, not, less than, equal to, greater than, smaller than, greater than, equal to, plus. There are as many options are available which you can use while writing your script. Got it? Okay. So, initially we will select while showing option in our condition type. Okay. And in every 1 second, I have put the once in the every second in the after every 1 milliseconds there. Got it? Then what we want, I want Okay, like in the we have taken an example of a switch and the lamp. So you have remembered then the tag name of the switch is SW and the tag name of the lamp is lamp. So I will put the first condition while showing that if my switch is 0, then my lamp will be off or the 0. Okay. Second condition, if my switch is 1, then I want my lamp should be on. Okay, so how you will write this condition? You can see in the figure, if switch is equal to 0, then lamp is equal to 0. This is my first condition. After finishing your condition, you have to add the AND if. AND if indicates that this is the AND of your first condition. Similarly, for the second condition, I want when my switch is 1, lamp will be 1, means when I turn my switch on, my lamp should turn on. And end of this statement, I have added AND if semicolon. Got it? These are my two statements or the condition which should be, or the script you can say, which should be satisfied while the run time or while showing. Okay, here you can see that if SW is equal to 0, here I have used 2 equal to sign, and when in lamp equal to 0 I have used 1 equal to sign. So there is a difference. Maybe many of you didn't know what is the difference between this. So when in the first, when SW is double equal sign there, this is called the comparison. Equal to, okay, this is equal to for compare, left hand side equal to right hand side, means when my switch is equal to 0, when my switch is equal to 1. So here in that, if you want to check between left hand side and right hand side, here you put the 2 equal signs. Okay, but after this we want if switch equal to 0, then lamp equal to 0. So here I have used only 1 equal sign, means it is not for comparing. We are not comparing that if lamp is equal to 0. No, here this equal is means whatever will be the lamp, the 0 will be stored in the lamp value, or lamp's value will be set to 0. Okay, got my point? And in the second, if the switch is equal to 1, then lamp value will be set to 1. So when you want to compare, we use 2 equal to sign. This is for the comparison. So when you want to compare between two cases, you use the double equal signs. If switch is 1, if switch is 2, here we are comparing. But when lamp, then lamp will be set to 0, lamp status will be set to 1 when you want to set or enter any value. So lamp will be set to 0, lamp will be set to 1. Here we will simply use the equal sign. Got it? Okay. And one more thing, when you add at the last of the instruction or the ending the script, you have to include the AND if. It indicates that your condition is finished or last. Then you have to add this semicolon at the end of your condition. Got it? Okay. So after there is one more thing. After writing the script, it also allows you to validate. You can see it at the right hand side, you get the option OK, cancel, convert, validate, all, string, mathematical system, add-ons, okay, miscellaneous, quick help. This are the toolbar or the options are available. So while writing one condition, it gives you freedom to validate. Okay. So after writing the script, you can validate the script. If there is any error, then it will show, oh, error is there. Okay. So for the precaution, you can check your script or validate your script at the end also, but while writing one line also, after writing one line also, you can validate. So while writing, keep writing, adding the lines on the script, you can keep checking with the validate button. So because sometimes what happen, you are this is just only 2 lines script I have shown, but in the practically there are many long scripts are there with long conditions. So if you are validating your script at the last, so there is chance that the error will be there. So it is tough to what you can say, check the error, in which line there is an error. Okay. So, it becomes the work, tedious work to check for to correct the error. But while writing, if it will also give it, you can also check your one line script and validate it. Okay. So, while writing the script or adding a script condition, you can validate it. Okay. So, it will add your efficiency of your script, okay, and it will reduce the probability of any error occurrence. Okay. After clicking OK, it will change its state from programming to the running mode. Okay. So, here you can see when the switch is 0, the lamp is 0, means red, and when the switch is 1, lamp is 1, the lamp color turns to green. Okay. So, this is the example in which I have used the script to connect the two devices, the switch and the lamp, okay, without tagging them. Okay, got it. Here now we will see the another example. Okay, you have remembered then in the lecture 37th, I think I have covered how you can write on the script programming or SCADA programming for the logic gates. Okay, we have used the AND tags expression there. Here we will also see how you can do it for the AND gate. Simply in the AND gate, similarly I have used the two buttons, switch buttons A and B, and an indicator Y. So, switch 1 tag is A, switch 2 tag is B, and the light tag we have used Y. I want to revise here that in the tag system, when you will click on the Y option, it will ask you for the expression wizard. In the light wizard, it will ask you for the expression. Here we have added A and B. That's all for the tagging process. But here we are using the script method to perform the AND operation. Okay. So, let us see how we can do it. So, the light tag is Y, hash is for display to the status value for both A and B switches, and for the Y light indicator we have used the hash, so that we can see the current status of the switches and the light indicator. So, here you can see for the AND operation we know that when both the A and B are 0, output is 0. For the 0 1 it is 0, for 1 0 it is 0, but when both the inputs are high, then only the output will be high. Okay. When both the inputs are high, output will be high, rest for all the cases output is 0. So, how we can write this in the script? Okay. So, simply we can write it, if A is equal to 1 and B is equal to 1, then Y equal to 1, else Y equal to 0 and if. So, the simple, I have written the condition when both the inputs are 1, output will be 1. Rest for all the 3 conditions, output should be 0. So, all the 4 conditions I have written in one statement or one line of script. If A is equal to 1 and B is equal to 1, then output Y is equal to 1. I want to revise that Y is the tag name of the lamp indicator we are using. Okay. So, when both A and B are 1, then Y is 1, else condition for rest of the other conditions Y equal to 0, and at the end you have to include end if in your statement, which indicates the end of your script. Got it? Next, after the AND, you have to remember, as per script, when the switch is 0, lamp is when the switch A is 0, B is 0, output will be off. When A is 0, B is 1, output will be off. When A is 1, B is 0, output will be 0 and 1. When the A is 1, B is 1, output will be 1, or it turns the color to green. Got it? Now, for the NAND gate. Okay, simple. Here another two switches A and B, okay, and the output indicator with the tag name Y. We know the NAND gate operation, when both the inputs are 0, output is 1. When A is 0, B is 1, output is 1. When A is 1, B is 0, output is 1. When both are high or 1, output is 0, which means we want output 0 when both inputs are 1, and rest of the other cases my output is high. Got it? What is the different condition? When both inputs are high, output is 0, else for rest of the other options or rest of the other cases, for 0 0 0 1 1 0, output is high. So what we will write in the expression? If A is 1, B is 1, then output lamp is equal to 0, else rest of the other cases y equal to 1. So simple, A is equal to 1, B is equal to 1, then y equal to 0, else y equal to 1, and if. Got it? So when 1 1, output is 0, else output will be 1. Okay, so just opposite of the AND. In the AND, 1 1, then y equal to 1, else y equal to 0. In the NAND, if A is equal to 1, B is equal to 1, then y equal to 0, else y equal to 1. Just the opposite of the not of the AND operation. Okay. Now for the OR gate, simple here also. We have taken two switches A and B with the tag name A and B, and the light indicator with the tag name Y. OR gate operation we all know. For the 0 0 output is 0, for 0 1 output is 1, for 1 0 output is 1, for 1 1 output is 1. So when both the inputs are low or 0, then only the output is 0, and for the rest of the other cases 0 1 1 0 1 1, output is 1 or high. So how we can write it in the script? So here we will see clearly, we will want 0 when both are 0, else we want the y equal to 1. Got the condition? Okay. So how we can write it? If A is equal to 0 and B equal to 0, then y equal to 0, else y equal to 1. Means when A is 0, B is 0, then only y is 0, and for rest of the other cases y will be 1. And if, keep this in mind, you have to add the and if at the last of the script. Got it? And the semicolon also. Okay. Now you can see in the figure, when both inputs are 0, then only your light bulb is off or red, and when any of the input is 1 or both the inputs are 1, output is 1, as we can see in the green light, seen by the green light indication of the light bulb. Okay. Now fourth is for the NOR gate. Same, two switches, tag name A and B, light Y. Okay. We know the NOR gate operation, when both inputs are 0, then only the output will be 1, and for any of the input is high or both of the inputs are high, output will be 0. Okay. So we will get only the high output or 1 output when A and B are 0. So how we can convert it in the script? Simple. If A is 0 and B is 0, then y equal to 1, else y equal to 0, and if. Okay. When both are 0, then only the y will be 1, else for the other condition y will be 0. Got it? So this is how we can write the, or we can implement the NOR gate using the SCADA programming. Okay. Now fifth for the XOR gate. So here is the same process. The tagging is same for A, first switch A, second switch B, and for the light indicator Y. For the XOR gate we know the logic operation is when both the inputs are 0, both the inputs are same. When input is 0 0, output is 0. When input is 1 1, output is 0. And when the inputs are different, means 0 1 1 0, then only the output will be high. Means when the inputs are different with each other or the opposite of each other, then only you will get the high output, and when both the inputs are same, A 0, B 0 or A 1, B 1, output will be 0. So how we can write this in the script form? When A is equal to B, simple. When both the inputs are equal or same, then we will get the 0. Yes, as we have seen in the truth table, when both the inputs are equal, A equal to B, then Y equal to 0, else for the other case, when not equal, A is not equal to B, Y equal to 1, and if. This is how, and this is the script for the NOR gate. When A is equal to B, Y equal to 0, else Y equal to 1. Now same for the XNOR gate. Two switches, simple, same components we have used. Here what is the truth table, what is the condition? When both the inputs are same, then we will get the high output. When both the inputs are different, means 0, 1, 1, 0, we will get the 0 output. So here when the inputs are equal, output is high. When the inputs are different, output is 0. So how we can write this in the script form? If A is equal to B, then Y is equal to 1, else Y equal to 0. And how you can end the script? By including AND if in your script. So if A is equal to B, Y equal to 1, else Y equal to 0, and if. So this is how we can implement the XNOR gate in our circuit. Now we will take another example to to get the better understanding of the script. Okay, here you can see in the figure there is one switch and there is one tank, you can see with the tag name T, and there are two valves V1 and V2. Got it? Okay. So how you can add the tank? Simple, you have to click on the wizard option, there you will get all the symbols of the tank, you will get the tank option symbol there. Okay, there are two valves V1 and V2. We have also included the hash option to get the current status display of the valves V1 and V2 and the tank. Got it? Now, what we want, what condition or the process we want here? We want that when the switch is on, valve V1 should be on and valve V2 should be off. Then the tank will start filling. After the tank level reaches 200 or the tank is full, V1 or the top valve will get off and the V2 valve will turn on. Now we'll get the outlet valve, means V2 here is the outlet valve, then the tank level will start decreasing. Okay, and when the tank level reaches to 0 again, V1 will turn on and V2 will turn off. This process will continue till your switch is on. Got my point? When the switch is on, okay, the valve V1, the inlet valve V1 will be on and the outlet valve V2 will be off. So your tank will start filling or the tank level will start rising from 0 to 100. Okay, when your tank level reaches 200 or when it is full, the valve V2 will turn on or the outlet valve will turn on and the inlet valve V1 will turn off. Okay, and the tank level will again start decreasing to the 0. And when it comes to 0, when the T level or the tank level comes to 0, again V1 will turn on and V2 will turn off. This process we want to continue in process in a loop till our switch is on. And when the switch is off, we want both the level or both the valves off, 0, 0 and T level should be 0. Got it? So how we can write in script? So just so you know how we can, you have to right click on the development window, you have to select the Windows script, then you for the type you have to choose a while showing. In the while showing we will put if SW equal to 1, then if V1 equal to 0 and V2 equal to 0 and T equal to 0, then V1 will turn on, means then V1 will be equal to 1 and if. So when the switch is 1 and all V1, V2 and T is 0, then we have to turn the valve 1 on, means then V1 equal to 1. Okay. Now the next condition, if V1 is 1 and V2 is 0 and T is less than 100, means if valve V1 is on, valve V2 is off and level of tank is less than 100, then T will keep increasing, means then T equal to T plus 1, end if, end of the script. Okay. Now, this condition, what this condition mean? Means our tank will start filling. Okay. Next condition, third, if V1 equal to 1 and V2 equal to 0 and T is greater than 99, okay, means it is more than 99, then what we want, that our first valve will become off, V1 will become off and V2 valve will become on. So, how we will write it? Then V1 equal to 0 and V2 equal to 1, end if. Okay. Next, if V1 equal to 0, V2 equal to 1 and T is greater to 0, then we want then T equal to T minus 1, means when the outlet valve is on, V2 is on, inlet valve is off, V1 is off and T is less than 0, we want to reduce or make our tank empty. So, we will make T equal to T minus 1. After, if V equal to 1 and V2 equal to 1 and T equal to 0, means when the tank level reaches 0, then again what we want, V1 equal to 1, V2 equal to 0, end if, means when the tank level reaches 0, then again we will open our valve V1, means V1 equal to 1 and we will close our valve V2, means V2 equal to 0, and if. So, this through this all the script we can complete or implement our industrial process. Got it? In the on-show, what we will write, when the switch is 0, means on-show, I have again repeating, what is the on-show? Means the condition we want before the run time, or you can say it like an initial condition, okay, before the run time. So, when the switch is 0, V1 is equal to 0, V2 equal to 0 and T will be 0, means both the valves are off and the tank level is 0. Okay, this is the on-show condition or the script, and above we have seen the while showing script. So, how it can include it? Simple, we have included the same script, you can see in the figure while showing, and then next in the, now we can see we will turn the development window into run time. So, then the step 1, when the switch is on, V1 is on, V2 is off and the level you can see the T level is at 60. So, our tank will keep filling, start filling. When it will stop? When the tank level will reaches to 100. Got it? So, now when the tank is full and the tank level reaches 100, valve V1 become off and now the outlet valve V2 will turn on. Now, after it turn on, now the tank will again start reducing, tank level will again start reducing. So, okay. So, it will keep decreasing. Here we can see in the third figure, step 2 the level become 50, okay, and the V2 is on here. So, next when it becomes 0 last, the valve will become off and then again V1 will turn on. Got it? So, that is all for this lecture. In this we learn how we can connect or interlink our components in the software, means how we can interlink our switch and the light indicator by using the scripts without using the tag system, like we did in the earlier classes or the earlier lectures. Okay. Here we learned about the SCADA scripts, then we learned how we can implement the SCADA scripts for the logic gates and or not, nor, NAND, XNOR and XOR. Okay. Then we have also learned the example, practical example, how to include the script or to how to implement the SCADA script for any practical application. Okay. So, that's all for today. Thank you and happy learning.